Hello everyone, we are live again with another session of Bootcamp 2020. Today we are going to cover the multiple services related to the notification service SNS. Sajja, do you want to add anything?
I just wanted to add that, the developers, I myself and Zeeshan, you also, Varis and Huma are lucky that they are coming into the mainstream development when the cloud has already taken over. Both of us have a long background. Not you are, of course, Zeeshan, a very young boy, but I'm talking about myself. A long background of monolith type of applications. We have been developing with .NET, Java, Node.js. The point is that this pandemic has basically transformed everything. And right now, thinking about an application which is not cloud-based in most scenarios, Varesh and Huma, is beyond me. That why would you develop it? And the apprehension which most companies felt about public clouds has more or less disappeared. It's already a $100 billion company, industry, and it is expected that the next year or two it will become a $200 billion industry. So what we have to do is for our careers, the next, if we have done most of the work, Huma. If we spend the next few months just focusing on becoming architects, cloud architects, understanding once you understanding the pros and cons of applying a particular strategy and how to develop event-based applications. There are very few people in the world, maybe in hundreds of thousands only, who can do this. And if we can become experts in this, and just because in every project, just starting from zero is very difficult. You have to have a background. You can't try and then fail and then do it because it takes too much time. The time to market is critical. So therefore, we are on the right track, and we will also start other boot camps, AI boot camps and other boot camps. But at this stage, let's start with Huma. She is going to give an introduction of the topic we are going to cover today.
Okay, Assalamualaikum. Since we have covered the introduction of SNS previously, today I'll just explain it with a simple example, though it's not quite technical that any example would require. But SNS is like communication simple notification service. And let's say I visit an e-commerce website, and in today's world, we can't imagine any website without any kind of notification service. As soon as I buy something, as soon as I purchase something, I actually get a notification that yes, I have purchased something. That is application to person. I get a notification, yes, I got it. And then as soon as I get notified that I have purchased something, the same application actually sends the notification to the bank or any kind of service I have provided the credentials of, to check whether my credentials are right or wrong, whether I have enough amount in my account or not. So that is application to application notification, which also works. So this is how cloud-based infrastructure needs to communicate. They need to communicate, and this is done through simple notification. Even one service within AWS is I can subscribe for notification as soon as I'm, for example, let's say I can subscribe for the restriction on my account. As soon as my account reaches $5, I want to be notified that yes, my account is exceeding the limit. That is itself a simple notification. We get notifications on password, some kind of one-time password kind of notification. So we can't imagine modern applications without these kind of notification services. And just like Event Village, we studied that we have producers and consumers. Here we have publishers and subscribers, and the logical unit which actually decouples both the client, publishers and subscribers is called topic. And instead of both the ends knowing about each other, we actually subscribed or enter the logic filtering and all that in the topic. So there's nothing quite too technical about this, and I hope this example makes up.
Cool. Thank you, Homa. So I'm going to share my screen and continue with the rest of the lecture. So first of all, I want to go through a few things in the documentation of SNS. So basically, as Homa has very nicely explained that SNS is basically a notification service, and she has also very nicely explained that why do we use it. So if you read this first paragraph, it says that SNS is a managed service that provides message delivery from publishers to subscribers. Okay, so we have some publishers and we have some subscribers. Publishers publish the message, and subscribers receive that message. So publishers communicate asynchronously. This is very important. Asynchronously with subscribers by sending messages to a topic. So basically, this line basically sums up the entire functionality of SNS. It's a very simple service that has a topic. Publishers push messages on the topic, and subscribers receive those messages. I have also actually made a small diagram to explain it better. Paint. Okay, so you can see there's a topic over here, and we have some publishers over here. These publishers send messages to the topic. So you can see messages are going from publishers to subscribers, and subscribers receive messages from the topic. So basically, topic connects publishers and subscribers. And the most important thing is that topic allows publishers to communicate with the subscribers asynchronously. Okay, so publishers are only concerned with sending messages to the topic. They don't really care about subscribers. They don't even know if the messages are going to the subscribers or not. They only care about sending messages to the topic. And likewise, subscribers are only concerned with taking messages from the topic. They don't even know about the publishers. Okay, so this is like one topic, but SNS can have many different topics. You can make many different topics, and then each topic would have its own publishers and subscribers. But so the question is that what are publishers and what are subscribers? So basically, they can be services. If I go down, yeah, it's written over here. Yeah, these are some examples of subscribers. So you can subscribe this service to the topic. So this is something. This is an advanced service. We have not learned about it, so just leave it for now. You can subscribe SQS. We will learn about this tomorrow. You can subscribe Lambdas, AWS Lambdas. So let's say that there was a Lambda function over here subscribed to this topic. So whenever there would be a message published to this topic, it would be received by the Lambda function in its event, and it would also invoke that Lambda function. So Lambda function would be invoked, and it would receive that message from the topic in its event. Okay. And then you can also have HTTP subscribers, like API gateways. Then you can subscribe your email to the topic. So you can subscribe your email to the topic. So in that case, whenever there would be a message in the topic, you would get an email. You would get that message in the email. You can also have mobile push notifications for mobile applications. You can also subscribe your number to the topic, and in that case, you would receive that message that was published to the topic as a text message in your phone. Okay, so let me first go to the console, and I'm going to show you how can we create topics and subscription from the console, and then I'm going to show you CDK examples. Okay. So you can see you have some topics over here. You can create as many topics as you want. Then you can also view your subscriptions. I just have one subscription. I think it's from another project. And then push notifications. These are from mobile applications, so we're not going to go through it. So let's first create a topic very quickly. It's very easy to make. Okay, so this is important. So you can see it says you can create two types of topics, a FIFO topic or a standard topic. Now, a FIFO means first in, first out. The first message that was published would be sent first. So in this kind of topic, you would the subscriber would be getting messages in a sequence, in a FIFO sequence. But in this standard topic, there would not be any promised sequence. But FIFO is slower, so you can see it's written that it can only publish 300 messages publishes per second. But standard has the highest throughput. They haven't given us a number, but it says it's the highest. And secondly, you can only use SQS as a subscriber if you're making a FIFO topic. But in the standard one, you can have many different services. You can have SQS, you can have Lambda, you can have HTTP. So we are going to be using standard most of the time for now, because we don't really care about this FIFO sequence, and it's faster, and we can see many examples with many services. So let's keep standard for now. Then it's asking for the topic name. That can be anything. This display name, this is optional. I'm just going to leave it. Now, some encryption options. It's optional, so I'm just going to leave it. You can actually encrypt your message. Then these are your my computer is stuck. Okay, so these are your permissions. Like what kind of permissions do you want to give to the topic? And retry policy, logging. Do you want to log the events from this service? Then tags. So I'm just going to leave all this optional stuff for now. We'll see some of this in the code. And now we have created our topic. And this is the information about the topic. Now we want to create a subscription. Okay. So that whenever a message is posted onto this topic, the subscriber can receive it. So we can click on create subscription. In protocol, so in the protocol, you can actually select the service that you want to subscribe to this topic. So if I had made the FIFO topic, then I wouldn't have these choices. I could only use SQS in the FIFO. But because I'm using a standard topic, I can use. I have a lot more options. So I'm just going to use email for now. And now it's asking for my email. So it's saying that after your subscription is created, you must confirm it. So it's going to send me an email, and then I'll have to confirm it. Now this is so these two things are optional, but they're very important. I'm going to skip them for now because they're optional, but I'm going to discuss them when I'll be discussing the code. But these two settings can be very useful. So create subscription. Okay, so if I go to topics, this is my topic. In this topic, I have one subscription, but it says pending confirmation. So I'll have to go to my email. So I'll have to confirm my email address, and it's confirmed. So if I refresh this page, so it says confirmed now. So this means now my subscriber is confirmed. Now it will receive all the messages that I publish on this topic. So the good thing is that we can publish topic from the console. Yep. So you can enter a subject, which is optional, but I'm just going to write it. So there are two options. So the first option is that if, like, right now we only have one subscriber to this topic. If we had 5 or 6 different subscribers and they were all different services, like one was email, one was Lambda function, one was SQS, you can actually send a separate message for each service. You can have a separate message for email, separate for SQS. But for now, I'm just going to use this one. Just going to send hello. And these are message attributes. I'm going to come to these later. They are optional, but I'm going to come to them later. They can be very important as well. So right now I'm just publishing a message with the subject hello and message hello. So I should receive this in my email. So I've got a message with subject hello, and this message hello. Okay. So now let's move to the code and let's see how can we do this with code. So we have quite a few examples in the repository. We have like 5 examples, but most of them are very similar. So let me first delete this. And delete the topic as well. Okay, now let's move to the code. So you can see we have 5 examples in the repository. I'm not sure if you guys can see it. I'm not sure how to zoom. Anyways, we have 5 examples. In the first 4, we are showing how to subscribe to different services, and in the 5th one, we're showing you how to publish a message from CDK. So I'm opening the first example. So let me zoom in. So in this first example, we are actually creating an HTTP endpoint and then subscribing that HTTP endpoint to our topic. So we are also creating a topic, we're creating an HTTP endpoint, and then we're subscribing HTTP endpoint to the topic. It's a very, very simple example. So if you guys remember from the previous examples, we can just create a REST API and then connect it with the Lambda function to handle the requests, and that becomes our HTTP endpoint. So we have created a Lambda function that does nothing. It only logs the event body, and then it is returning hello world to the API gateway. This API gateway, and this API gateway is this Lambda function is referenced in this API gateway. So they're both connected. Okay. So basically, the URL of this API gateway is going to be subscribed to our topic. So this is old stuff. We already know this. Now coming to the new stuff. So then we created a topic. Now this is very important. We need a topic to send a message, right? So we created a topic first using this library SNS, and then on that topic, so you can also add some parameters over here. You can check them out from the CDK documentation, but we have not added any. So this means that all the parameters are optional. And then to that topic, we have added a subscription, .add subscription. And what kind of subscription? We want to subscribe a URL, an endpoint, HTTP endpoint. So if you had to subscribe Lambda function, you would write Lambda subscription over here. But for now, we're going to leave it to URL subscriptions. And then which URL? This URL that we made up here. So API URL would give us the URL of this HTTP endpoint. And then we have also defined a protocol. Now you usually don't have to define the protocol. So you can see you have many different protocols. Like if you're using Lambda, you would have to write Lambda, but you usually don't have to do this for other services because CDK does it by itself. Like L2 constructs do it for you. But in this case, you actually have to define it because subscription URL can be of 2 types, right? An HTTPS URL or HTTP URL. So in this case, we're saying we want our URL is HTTPS. Okay. But like if you were using Lambda subscription, you can actually remove this line. It's going to be optional. So, and that's pretty much it. It's a very simple code. We created a topic, we created our endpoint, and then we added our endpoint as a subscription to this topic. Now this is a very simple example. The next step would get the next step is a bit more interesting. It has a few more things. Let me just quickly deploy this. So basically, whenever we will publish a message on this topic, our Lambda function would, oh, I did not save it. Can you change? Let me open it up again. Yeah, I just thought I'm like I wrote something and I was scared that it's gonna give it might give us an error. I'm just gonna deploy it. Basically, whenever there would be a message on this topic, our endpoint would receive it, and our endpoint requests are handled in Lambda function. So this Lambda, so we can actually, so this Lambda function would actually receive that message in its event, and we are logging this event. So we should be able to see the message in the Lambda functions console or the CloudWatch in the Lambda functions logs. So let's wait for it. Okay, it is done. So if I go to my topics, you can see we have one topic over here that we just created. And in that topic, we have one subscription, but it says pending confirmation. So it should have sent us a confirmation URL to our HTTP endpoint, and that was connected to our Lambda function. So we should have received something in our Lambda function. So let's see, what is it? So it sent us. Okay, so here you go. It sent us a subscribe URL. So we actually have to run it and confirm the subscription. You just have to do it once in the beginning, and then after that, whenever a message is published on the topic, we should receive it. I think let's run it over here. I'm not sure if I copied the right thing. Let's see. Okay, it's confirmed now. I'm not sure why what's showing this. Anyways, so we are subscribed now. Now let's publish a message on this. So right now I'm publishing messages from the console, but in the last step I'll show you how you can publish messages from the CDK. So no. Publish. Now we should have received a message in our logs. So here we go. So here's our subject, here's our message, and yeah, that's it. So that was our first step. It was pretty simple. So before moving on, I'm just gonna deploy it so that we just have one topic at a time. Otherwise, it gets confusing. Moving on to the next step. So in the next step, you're subscribing Lambda function, but there are a few new things over here. Okay, so Now, because we're subscribing a Lambda function to our topic, first of all, we need to create a Lambda function. And what is inside our Lambda function? It's just logging the event. Okay, now you can see I'm logging some weird thing, a weird object, but it turns out that the message from the SNS comes over here. So that's why it looks weird. So it comes in record, and then records have like many weird messages. So the one that is on the 0 index makes the most sense. So you can actually log out the entire event if you want to, but I just did this so that we can clearly see the message in the logs. So first of all, we have created a Lambda function that would be subscribed to our topic that we will create. And then we have created a topic, just like the previous example. But then you can see there's a new thing over here. We have created a dead letter queue. Now, what is this? Now, to actually explain, so you can see we have actually created it using SQS, and we have not yet studied SQS, but let me try and explain it to you. And to explain this, I created another diagram. Okay, so this is similar to our previous diagram. We have a topic, we have publishers, and we have subscribers. Okay, but you can see we also have a dead letter queue. Now, what happens if publisher sends the message to the topic and the message fails for some reason? Like the publisher wouldn't know about it, the subscriber wouldn't know about it, only topic knows about it, right? So that's why we can actually connect a dead letter queue. It is named dead letter queue. You can say we can connect temporary storage that can actually save the failed messages, and we usually call it dead letter queue. So basically, if publisher sends some message to this topic and it fails to go to some subscribers, or subscribers rejects it, it can actually go to the dead letter queue. That's all you need to know. It's just a temporary storage that saves our failed messages. Now, like, why do we need to save failed messages? Okay, now this is a good question. Well, I think it depends on your application. Like, some people might want to run some analytics on the failed messages. Some people might want to test their efficiency, like how many messages are actually going to the subscribers. And you may also want to implement a retry mechanism or a fallback mechanism, like if you might want to change something if something fails. So yeah, so we have an option of saving the failed messages through a topic. Now, this dead letter queue, now just take my word for it that it's a temporary storage. We have implemented it using SQS. So SQS is not exactly a temporary storage, but just take my word for it for now that we are only saving. So you can actually send these failed messages to some other service as well, like Lambda function, but we are not doing it right now. So if I go back to the code, so you can see our dead letter queue is made using SQS. So SQS has queues, like SNS has topics, SQS has queues. So we have created a queue. We have named it, you can name it anything. We have named it my subscription underscore dead letter queue, DLQ. And the retention period tells us that for how long do we want to save those failed messages. So we have written 14 days. So you can say that it's, for now, you can just assume it to be a temporary storage that is just saving our messages, failed messages, only the failed messages. So
Varis, I would like to ask a question. For example, if there are more than one subscriber, and if that doesn't reach, it reaches one and does not reach the other. Let's say there are two. Will it be placed in dead letter queue?
I think so. I've not tried that, but I think so. It should be.
Logically, it should be.
It should be, yeah. So we have created our dead letter queue. Okay, that is saving our failed messages. So if everything goes right, then the messages don't go into the dead letter queue. Usually it would go from publishers to subscribers, but if something goes wrong, then it goes to dead letter queue. Okay, then the topic we created, we are adding a subscription to it. Add subscription, and what kind of subscription? Lambda subscription. Okay, and which Lambda function? this Lambda function that we created up here. And then you can also see we have a reference Java directory queue over here, the queue that we created over here, right? Now, but you here filter policy. Now, what is this? Now, in the previous example, we did not have a filter policy, and that meant that any message that is going on to the topic would be received by the subscribers. It doesn't matter what the message has, right? Like every message was going to the HTTP endpoint. But in this example, we are saying no, we don't want our Lambda function to receive all the messages. We only wanted to receive those messages that are satisfied by this filter policy. So you can say it's kind of a filter. Yeah. So it's actually very confusing how they make us define it, but I'm going to try and explain it. So basically, let me repeat this: that only the Lambda function would only receive the messages if it satisfies this filter policy. So if it doesn't satisfy this filter policy, the Lambda function would not receive it. Neither would it go to the dead letter queue. So it would not go to the dead letter queue. The Lambda function would also not receive it. So it only goes to the dead letter queue if it fails. In this case, it is not failing. We're just not, our subscriber is just filtering it out. So let me explain the filter to you. Now you can only implement filters on JSON text. Just take my word for it. I'll explain it later why. You can only have filters on a JSON object. So in this case, we are saying that the Lambda function should only accept the message if the JSON object that we pass into the message has a key named test. It should have a key named test. The value of that key should have it should have a numeric filter, and that numeric filter should find out that if the value is between 100 and 200. So only the value that is between 100 and 200. Sorry, let me rephrase that. It will only pass on the message to the Lambda function if the value of the test key is between 100 and 200. So if it's 150, this message is good to go to the Lambda function. If it's 120, it's good to go. If it's 99, it's not good to go. It will filter it out. Lambda function would not receive it. If it's 250, Lambda function would not receive it. Right. So let me repeat this again. It's saying that the message should only go to the Lambda function if it has this JSON object with a test key, with a key named test, and the value of that key should be a numeric number because we are applying a numeric filter, and it should be between 100 and 200. Now, if this test is not there, even then it's not going to be sent because this is also part of the condition. But it would only go to the Lambda function if we have this key, and the value of this key is between 100 and 200. Now, there are many different filters you can implement. And for that reason, I have used different filters in different examples. You're going to see a different filter in the next example, and I'll explain that as well. But yeah, you can view all the filters. You can see all the filters in the documentation. So now let me deploy this, and then I'll explain you why did I make this a JSON object, because it doesn't say anywhere over here that it's going to be a JSON object. So let me. So basically, if I had written something else over here, then that should have been over here. You're getting it right. So this is basically the key that is being expected in the message, and this is and this is the value that is being expected in the message. And value has a separate filter. In this case, it's a numeric filter. If it's a string, then we can have different filters for that as well. And this is completely optional. You can actually remove it if you want to. Like we did not have this in the first example. Even the dead letter queue is optional. You can remove it, and in that case, all your failed messages would just be lost. You would not even know about it. Okay, it's done. So this is our new topic, and you can see the Lambda function. You don't have to confirm anything in the Lambda function. It comes confirmed by default. You only have to confirm it in the email and in the HTTP endpoint, and I think text message as well. So you can see the protocol is Lambda. It figured out itself. So yeah, now let's send a message. Let me also open the Lambda function. Okay, publish message. Now this is completely optional, but I'm just gonna write hi over here. Okay, so the filter that I showed you does not apply on the message body. Like you can enter anything over here, doesn't really matter. You can make a JSON objective here and add that condition, but it doesn't even look for that condition in this body. It only looks for those filters in the message attribute. And message attributes are JSON by default. So you can actually add a key. This is a key. Sorry, this is your key, and this is your value, and this is the type. So message attributes are, you can say, additional message. I don't know, additional part of your body, but it's in JSON format. So it says that message attributes let you provide structured metadata items such as timestamps. You can pass timestamps in it, geospatial data, signatures, identifiers, and this is completely optional. But if you have implemented a filter, then you would obviously have to put something in here. Otherwise, if I don't write anything over here, it would always get rejected because my filter is expecting this object, an object with the key test and of some value between 100 and 200. So I'll have to write it over here. First of all, I'm going to show you. First of all, we're going to satisfy the condition, and then I'm going to write something else, and then let's see if the Lambda function receives the unsatisfied message or not. So our type is number. So the name should be test, and the value should be between 100 and 200. So I'm going to write 150. This should be received by the Lambda function because this is satisfying our filter, satisfying our condition.
Zeeshan, I think Varis says computer is not.
Yeah, it seems.
Is hanged. You will have to call
Let
him.
me just call him. He's just joining in a moment. Okay, so meanwhile, Waris is joining. Basically, the point Waris was trying to explain. Oh, he's back.
Sorry, I got disconnected. So where was I?
You were showing the filters. You have to share your screen.
Oh, okay.
You were explaining the filter metadata filters.
Okay. So let me just repeat everything again. So the filters are not applied on this body. So you can see when we publish a message, we have a subject that is optional. Okay. Then we have a body, but we also have some message attributes. So the filter doesn't apply over here. It doesn't matter whatever you write over here. It won't go through the filter. Filters only work on the message attributes. That's why I said that it has to be JSON. We define filters in a JSON object because these message attributes are JSON by nature. So you can actually write this is your key and this is your value and this is the type of value. So filter only looks for the message attributes. It doesn't really care what is in the message body. And what do we usually send in the message attributes? It is just like you can send it's additional information. Like you can send information about timestamps, geospatial data, signatures, identifiers. Now, if you have so this is basically optional, but if you have defined your filters, like if my filter is actually expecting this key and then a value between 100 and 200 in the message attribute, so I actually have to define a message attribute. If I don't define it, then my subscriber would not receive the message. So it's expecting the key name should be test, expecting a key name of test, and then it's expecting a value between 100 and 200. So I'm going to write 150, and let's send it. Oh, send it. Now let's see if our Lambda function has received it or not. Okay, so we have got one log, and okay, we have received it. You can see subject hi, hello, and then message attributes test in value 150. Now let's send another message, but let's let's send a value of less than 100. Let's say 80, and let's see what happens now. Now the Lambda function shouldn't even be invoked. It shouldn't receive this message because it is this. Now this thing is not satisfying our filter because our filter is saying that we want a value between 100 and 200. Now we shouldn't be getting any new logs over here. Okay. So okay, we have not received anything. Right. Okay. So let me just publish once more. So hello again. Let's make it 199. Now we should receive another message over here. Okay, so we received another message, and we are still satisfying our condition because it's less than 200. So this sums up our second step. Let me just quickly destroy it. So we saw two new things over here. The dead letter queue, which was made using SQS. And then we also saw filter policies, which were like a little weird to describe in the CDK, but they can be very useful. Okay, so the next step is okay. So in this step, we are actually subscribing SQS queue, which we have not studied yet, but I'm gonna try and explain it. Okay. Well, this is a very interesting example. Okay, so first thing what we have done is that we have created our topic, just like previous examples. Now this example is pretty much the same. We're only replacing Lambda function with a SQS queue. So after creating the topic, we create a queue that would be subscribed to the topic, and then we create another queue, which is our deadline queue. So you can see we have two queues in this example, but one of them is our main queue that replaces the Lambda function, which is subscribing to our topic. The other one is the dead letter queue that would only receive the failed messages. So if the message is successful, it would go to this queue. If the message fails, it would go to dead letter queue. And in the dead letter queue, we have defined our retention period to be 14 days. And then my topic is add subscription. Now, what kind of subscription? SQS subscription. And then we have referenced this queue over here because this is the queue that is subscribing to the topic. And in the dead letter queue, we have referenced the other one, which is acting as a dead letter queue. I will actually also show you the dead letter queue in the console after deploying this example. And over here, again, we have defined a filter policy, but this time it's different. So this time we are saying that, again, we want the key to be test, right? But now this time we're saying the value would be a string because we are applying a string filter. And in the string filter, we are saying the whitelist basically means allow these values. So we're saying that our queue would only receive the message if this is there in the message attributes. Now whitelist means that allow this message, allow this string. You can have more than one word over here. Okay. So if I write something like this, it would not allow because that's just not there. It has to be there. And then there's also a blacklist, I believe. Yeah. So if I wrote blacklist over here, this means that the message would be received by the subscriber if it is anything but test. So in this case, it would not be received by the subscriber. If it's anything else, ABC or whatever, it would be received by the subscriber. But as soon as it gets test, it would not be received by the subscriber if we use the blacklist filter over here. But let's take the whitelist for now. So we need to enter this thing in our message attribute, and only then our queue would be getting this message. Now, before proceeding, I would actually like to discuss SQS a little bit. Yeah, I might be going a bit off the topic, but yeah, I might as well explain it. So because we have to learn this tomorrow, so I might as well just explain it a little bit right now. So SQS is a very important service. So it is basically a very important part in the event-driven architecture. You can say that it is a smaller version of EventBridge. Yeah, it works very similar to EventBridge. So the first application is it can be used as a data queue, as we have seen with the SNS with some other services as well. So that is one application. The other application is to use it just like EventBridge. So it can actually be used to connect two services asynchronously. And okay, so basically it is also a message delivery system like SNS, but there are two major differences between SNS and SQS. So SNS has topics, SQS has queues, which are different. And we usually use FIFO queues, first in, first out.
Zeeshan, I think we have the same problem again.
Yes, I think we lost him again. Just a moment. He's joining in a moment.
Yep. Sorry again, got disconnected. So let me just repeat this again. I was just quickly briefly explaining SQS. So SQS are just like.
Share your screen, please.
Oh yeah, sorry. Okay, so SQS are very similar to Event Bridge. So you can say it's a smaller version of Event Bridge. Like Event Bridge is global, any service, like it supports a lot of services. But if you have to use SQS, you will create a new queue and put it between two different services. So it's a smaller version of Event Bridge, but it is used in a very similar way. So basically, there are a lot of applications of SQS, but one application that we saw already is the data letter queue. It can be connected with other services to capture the failed messages, and then another application that I'm discussing right now is its ability to work as a substitute for Event Bridge. So the basic difference between SNS and SQS is that, but both of them are message delivery systems. Both of them save messages, but the main difference is that SNS sends messages through topics. SQS sends messages through queues. They're quite different. We'll discuss that tomorrow, I guess. And the second difference is that in SQS, the topic is responsible for sending messages to the subscribers. So subscribers don't have to do anything. They're just sitting there waiting for the message to arrive from the topic. But in case of SQS, the queue doesn't send message to anyone. The service that actually wants to read the messages from the queue actually has to poll the queue. So this is the second difference, right? But let me see if there's anything else that I can talk about. So okay, when do we use SQS? So this is a very good example that explains how can you use SQS in an event-driven architecture. So in an event-driven serverless application, it is very common to see SQS being used as a buffer. Consider the example where we have a very popular website that has users placing 100,000 orders every minute, but the order processing system that we created is slow and only able to work with 10,000 orders every minute. If we directly connected our order processing system to our website with an API call, then our system will not be able to handle so much load, and it will result in errors and lockdown, right? So to avoid this situation, where we have a slow downstream consumer, we can put an SQS queue in between the API and our order processing system. This way, all the orders will keep getting stored inside the SQS queue, and our order processing system will be able to pull the orders at the speed which it is able to handle. So this is basically saying that if you have like two services, an upstream service and a downstream service, and they are connected together synchronously, but the upstream service is working much faster and sending a lot of messages to the downstream service. It is sending messages at a much faster rate than the downstream service can handle. So what would happen? Most of the messages would get lost in a synchronous system. But it's saying that if we connect them asynchronously and add a queue in between them, then the upstream service, which is faster, would send the messages to the queue. The downstream service would be getting messages from the queue at a slower rate, but those extra messages would not be lost because they would be saved in the queue as a buffer, right? So it basically allows you to connect two services asynchronously, just like we used to, just like the event bridge does, right? So this was a summary of SQS, like how we actually use it in an event-driven structure, but we'll study details tomorrow. So sorry, I went a bit off the topic. So let me deploy this.
Meanwhile, there is a question. A student is asking, what is the difference between normal queue and dead letter queue? So there is no difference. Basically, both are the queues, but the objective, the purpose we are using them are different. So the normal queue will be using to send messages to different services or consuming to the different services. In case of dead letter queue, we are actually specifically using that queue inside in a subscription, so that if that particular SNS notification gets failed, so that message should be written on that dead letter queue, in that particular queue. So we call it a dead letter queue. Correct me if I'm wrong, Waris. Waris, I guess we lost him again.
Okay. Okay, it has been deployed. So you can see this is also confirmed by default. So let's quickly publish a message on the queue. In the message attributes, now it's a string. What else was there? So it has to be test. Okay. So the key is also test, and the value should also be test. Okay. And let's go to our SQS service, simple queue service. And you will see two queues over here. One is our dead letter queue, and one is our this queue, the main subscription queue. So let's first open the dead letter queue. So as I told you before, that you actually have to poll for the messages from the queue. So I'm going to start polling. It's going to poll for a few seconds. Now this queue shouldn't receive any messages unless and until our message failed. I'm just going to stop polling for now. So we haven't received any messages. In the second queue, send receive messages. So we're going to poll for messages. Okay, it has. You can see we have received one message, and this message came from SNS. And you can see our message, our subject, and then this is our key, and this is our value. And we received this message because this thing satisfied our filter. Okay, now I think that's it for this step. Okay, now moving on to the next step, email subscription. We have already seen this. I might not even deploy it. I'm just going to show you the code. So again, we have created our topic, a dead letter queue. This is option. You can actually remove it as well, and then add subscription. And what kind of subscription? Email subscription. And then you can add your email over here. I'm going to add waris.hassan. So my email would get subscribed to the topic. And then you can see we have a new parameter over here. So if you're sending a JSON message and you want to receive it as in the JSON format in the email, then you can put it to true. Otherwise, if you want to receive it as a string, then in the string form, not in the JSON form, then you can leave it to false. And that's it. Nothing new over here. So I'm not going to deploy this because we have already seen the email example that I did in the beginning using console. So this is how you do that in the CDK. Next example is SMS subscription. No, I want to do this as well, because you guys would get my number and my nights would be sleepless. I'm just going to explain the code. So here we define the topic again. Dead letter Q again. It's very similar. All the examples are similar. If you understand one, you understand them all. And then SMS subscription, you enter your number over here, and I've defined this different filter policy over here. So it's saying that again the key would be test, but the value should be greater than 100. Only then you would receive a text message. So I'm not going to deploy this as well. Now this takes us to the last example. Now this is a quite different example, because in the previous 4 examples with the topic. Now this example is very similar to what we saw in the event bridge example that Zeeshan explained, in which we had a producer lambda and a consumer lambda. So in this example, we have the similar producer lambda with the exact same code. But instead of the consumer lambda, we have our SNS topic. So our SNS topic would be the consumer. So we have created a producer lambda function, and the code, the handler code, is very similar. So what it's doing is it's creating an event and putting it in the event bridge. So we're using AWS SDK, AWS SDK library to import this, and we're initializing our event bridge. And then in the event bridge we have this function put events, and in the put events we write the JSON. We write our event in the JSON format. So the event bus name, this event is going to go to the default bus source. Now you can write anything in here you want to, but make sure that when you are actually receiving the events, you put the same thing in the target as well. Sorry, rule in the rule as well. So this function is just creating an event and putting it in the event bridge, and that's it. So we have already seen this code. It's like I just literally copy pasted it from the event bridge example. Okay, and then here we are actually granting permissions to this Lambda function so that it can put the events. And then we have created our topic. Now this topic would act as a consumer, like we had a consumer Lambda in the event bridge example. In this example, the consumer is our topic. And then we have created our data queue, completely optional. And then we have also added a subscription. So in this, I'm just going to write my email over here. In this case, we're using an email subscription. And then we have created our rule. So whenever this producer Lambda function creates an event, we don't want to receive all the events, but we only want to receive certain events. And what kind of events? Only the events that are produced by this producer Lambda. So we have to write the same source in the rule, producer Lambda and producer Lambda. Okay. Now I'm not going to explain this in too much detail as well, because we've already seen this. So this only means that we are only interested in the events that are coming from the producer Lambda function, because we have defined the same source in our rule. And then for this rule, we have added the target. And what is our target? Our consumer. It is our SNS topic. We've referenced our topic. So let me explain the flow again. So what would happen is that, first of all, the Lambda function, whenever we will run the Lambda function, it will generate an event. That event would go to the event bridge, and from the event bridge, and if that event is from this source, then that event would be received by the SNS service, and that SNS service would send that event as a message in this topic. Okay, and the subscriber of our topic is our email. So that event would be sent to us in our email. Let me repeat this again. It sounded very confusing. So whenever we will run our Lambda function, it will generate an event. That event would go to the event bridge, and from the event bridge, it would because we are polling for the events that are from this source, we will take that. Our SNS would take that event, and that SNS would send that event as a message to our topic. And this topic is going to send that message to all these subscribers, and in this case we only have one subscriber, that is our email. So you can see the event generated from this function would be sent to our email, and there's so many services involved in between. So let's deploy this. So you can actually see that events, whenever the SNS receives an event, it gets published as a message to the topic. So this is one way of publishing messages to the topic. Like in an event driven structure, you might want to send an event to some, like you might want to send an error event. You might want to send an email whenever there is an error event. So you can use this method. And the other way of publishing messages through SADK would be using it in the Lambda function, like using SDK. So if I can open AWS SDK SNS. So like we are creating and producing an event over here using SDK, Event Bridge SDK. You can also publish a message to any topic using SNS SDK. So there should be a function called publish. Yeah, here you go. You can just use this function with these parameters, and then it would send a message to your topic. You can give your topic URL over here, the message over here, message attributes over here, if you have any filters. Yep. So this is the second way of doing it. We have not included this in the repository because it's not CDK exactly, it's SDK. But this one is more interesting because this example is actually sending the event as a message.
Marish, are we done?
Yeah, I'm just going to test this and then we are done.
I was suggesting to Zeeshan, you and Huma, that let's jump SQS for the next class and go directly to pinpoint and step functions, because you have already covered SQS more or less.
Okay. Okay, so when I'll run this function, I should get the event generated by this function in my email. I'm just going to test that. Okay. I don't really care about the event that is going in the Lambda function because I'm not using it. Let's see if it works or not. Okay. Seems okay. Have I received? Okay, I've received a message. Oh. What? I think I'll have to subscribe first. Oh yeah, I'll have to subscribe first. Now when I'll run the Lambda function, now I should receive the message. Mhm. I think something is wrong. Let me just have a quick look. Confirmed. Let me run it once again. Yeah, I'm not getting the message. I'm not sure why. Should I try and debug it, or like are we out of time?
I think we are out of time.
Okay. Okay. So yeah. So I think it should work. Like if you go to the repository, you can. I think I might have changed something, but yeah, it should work because it's already tested. So you can check it in your own time. It's a very interesting example. So yeah, I think that's it for today. Just gonna stop
Okay,
my
and
share.
for all the students, we are going to move over to step number 19. We are not going to cover step 18 in detail in class SQS because Varis has already given you the theory and also shown you how to in data queues how to do the coding. So therefore, it's more or less covered. So we are going to go over to pinpoint and then to do step functions. Thank you, everybody. Bye.
Okay. Bye bye.
Okay, bye.